Let us look at proposition number 14 of book 5 of Euclid's Elements. The proposition says, if a magnitude, if a first magnitude has to a second magnitude the same ratio as a third to a fourth, and the first is greater than the third, then the second is also greater than the fourth. If equal, equal. If less, less. So what this basically means is that A is to B is equal to C is to D. If A is greater than C, then B is also greater than D. If A is less than C, then B is also less than D. And if A is equal to C, then B will also be equal to D. That's what the proposition says. Proof is very straightforward. Now we are given that A is to B is equal to C is to D. And we have three cases here. A can be greater than C, equal to C, or less than C. So let's take A is greater than C. Now let's compare A and C with B. Right? So A is to B, or rather compare the ratios of A to B and C to B. So A is to B is going to be greater than C is to B. Why? Because A is greater than C and B is another magnitude with which we are doing the comparison. Remember, we already started with A is to B is equal to C is to D. And just now we have seen that A is to B is greater than C is to B. So combining these two, we end up with C is to D is greater than C is to B. C is to D is greater than C is to B, which means what? That D is less than B, or other way around, B is greater than D. So here basically we are using propositions 5.8, 5.13 and 5.10. So if the ratios are equal, if A is greater than C, then we have shown that B is also greater than D. Similarly, we can prove that A is less than C, then B is less than C, and if A is equal to C, then B is also equal to D. So that was proposition 14 of book 5 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share it. That's it for now. Bye.